welcome to section 1.4. We are not covering objective 3. Okay, so here's a question. What should you always include when you solve a word problem? I have mentioned this in other videos. Well, there are a few things. One, you should have a let statement. This is where you introduce your variable. Or you draw a diagram. Second thing you should have is an equation. Third, you should show solving. And lastly, number 4, you should have a sentence. And this is a complete sentence with a capital letter and a period and your units. Okay, so those are the 4 things you should always include when you solve a word problem. Let's take a look at example 1. If you have 3 dimes, 4 nickels, and 2 pennies in your wallet, how much money is that in terms of dollars? Well, what do we have? We have dimes, nickels, and pennies. And then we want to figure out the final value in dollars. So I'm going to let M equal total amount, D equal dime amount, N equal nickel amount, and P equal penny amount. Ooh, I just spelled that wrong. Penny amount. Spelling, not my forte, but I work at it. Okay, the last thing is the unit. We want to know how much it's in dollars. Okay, so what I want in my equation is I want that M is going to equal, well, how many dimes do I have? I have 3, so 3 dime, plus 4 nickels, and 2 pennies. Let's see, what is dollars in terms of, what is nickels in terms of dollars, dime amount in terms of dollars? Well, that is 0.10, 10 cents, right? And then 4 times, and what is nickels? Nickels is 0.05. And then pennies is 0.01 of a dollar. Okay, and then multiplying that out, let's see, so M equals, and we would have to do this scratch work on the side if you need to. So scratch work. So we have 0.10 times 3. So that's going to be 3 times 0 is 3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 0 is 0. Let's see, we had 2 decimals total, so 1, 2, 0.3. Let's do the other one. So we have 0.05 times 4. Multiplying 5 times 4 is 20. 4 times 0 is 0, but we add the 2, so we get 2. And then 4 times 0 is also 0. How many decimal places? 1, 2, boop, boop, right there. And we can just drop the extra 0. Plus, and then lastly we have the 0.01 times 2. So 2 times 1 is 2. 2 times the 0, 0. And 2 times that other 0 is 0. Moving the decimal over 2 places, we have 1, 2, boop, right there, 0.02. Okay, and adding that up, M is going to equal, we'll have 0.52. Alright, so how much money do we have? We have $0.52. Notice we wouldn't answer 52 cents because we were told to answer in terms of dollars. Okay, example 2. For a bill totaling $5.65, a cashier received 25 coins consisting of nickels and quarters. How many of each denomination of coin did the cashier receive? Okay, so I'm going to go ahead and say let X equal number of nickels. And we're told there's 25 coins total, so I'm going to go ahead and use X to describe quarters. Well, if she used, let's say she had 10 nickels, how many quarters would she have? Well, we just do 25 minus 10 to find out the number of quarters. But we don't know the actual number of nickels, which we called X, so 25 minus X would describe the number of quarters. Okay. So we have that and we have that. The next thing we need to figure out is, well, how many of each one did she receive? Okay, so it was a bill totaling of $5.65. So we know that however much money, or however many nickels they had, plus however many quarters they had, should equal $5.65. But I'm not just going to put down X. Why? Because that's talking about the number. That's not talking about the dollar amount. I want to describe it in terms of dollars. So how much is a nickel worth in a dollar? Well, 0.05. So X times 0.05 would give me the amount of money I have with the number of dimes I have. For example, if I had 1 dime times 0.05, I have 5 cents. If I have 2 dimes times 0.05, I have 10 cents, and so on. Except we don't know how many dimes we have. Sorry, we don't know how many nickels we have. Sorry, I was using dimes there. We don't know how many nickels we have, which is why we write X next to the 5 cents. Same thing goes for the quarters. We're going to go ahead and do the 25 minus X, but since we're talking about money, we have to multiply it by the denomination, or how much quarters are worth, which is 0.25. Okay, so we have our equation now in terms of dollars. All the numbers have to do with dollars, so let's go ahead and multiply out. We have 0.05 times X plus 0.25 times 25 minus X equals 5.65. Now, I don't know about you, but I don't really like having all these decimals around. I'm going to go ahead and get rid of them by multiplying by 100 to both sides. That 100 will distribute into both of these terms, and we'll get 5x plus 25 times 25 minus x equals 565. Okay. Solving, let's get rid of this parentheses here. We'll get 5x plus, so 25 times the 25, minus the 25 times the x equals 565. Okay, so 25 times 25. Let's go ahead and do that on the side. 5 times 5 is going to give me that 25. 5 times 10, sorry, 5 times 2 is 10. Plus 2 will be 12. Add that 0 for the next round we're going to do. And then continue. 2 times 5 is 10. Let me go erase that 2 from the previous round. So 2 times 5 was 10. 2 times 2 is 4. Add that 1, we get 5. Add them up, we get 5, 2, 6. Once again, if you need a reminder on how to do that by hand, please come to office hours or send me an email. Okay, so we have 5x plus 625 minus 25x equals 565. Okay. Let me fix that. 5, it didn't look like a 5, that looked like a 6. Alright, let's see. Solving, we want to get the x's together, so let's go ahead and add up those x's. We'll have 625 minus 20x equals 565. I'm going to go ahead and add the 20x to both sides. And in the same step, go ahead and minus the 65 from both sides. Sorry, minus the 565. Okay, so we have 20x equals, and I don't know what 565 is. Actually, let me go ahead and move my work over. I'm going to move that over there to the side, keeping my scratch work over there. Let me erase this, draw out some scratch work. Okay, so we're trying to do 625 minus 565. 625 minus 565. Let's see. Well, the 5 minus a 5 is going to be 0. 2 minus 6, we can't do that. We have to borrow from that 6, that'll become a 5. Carry that 1 over, so then it'll be 12 minus 6, which is 6, and then 5 minus 5 is 0. So we have 60. So 60 equals 20x. Let's go ahead, carry this on up here. 60 equals 20x. Alright, dividing both sides by 20 to get that x by itself. We'll end up with 3 equals x. Awesome! Okay, what was our question? It was how many of each denomination did the cashier receive? Well, we knew x was the number of nickels, so we received 3 nickels. How do we find the number of quarters? Well, we'll do 25 minus x to find the number of quarters. Let's do finding number of quarters. Once again, if you're running out of space, make sure to label your work. So we're going to have 25 minus x is going to equal 25 minus 3, which is 22. So the number of quarters is 22. So let's say here, she received 3 nickels and 22 quarters, period. Okay, moving along. Example 2. 2 cars leave the same town at the same time. One travels north at 60 miles per hour and the other travels south at 45 miles per hour. And how many hours will they be 420 miles apart? Okay, right off the bat, I know this is a miles per hour problem. Why? We're talking about speed and distance. So the formula that comes to mind is distance equals rate times time. I don't know where to apply it yet, but that comes to mind. Now, is there a visual we can draw with this problem? Well, there is. We're talking about north and south, right? So one travels north from a starting point, and the other one travels south from the starting point. And then what happens? We want to figure out when that distance, when their total distance is equal to 420 miles per hour. We're going to add at what time is the distance equal to 420 miles per hour? So what do we not know? We don't know the time. So I'm going to go ahead and let x be our time. Let x equal the time. Okay, so then what do we know about the distance this first car is traveling? The little car, I'm going to go ahead and draw him in. He is traveling, well, if I used a distance equals rate times time, his distance, we don't know, we'll call it distance 1, is going to be equal to his rate, which is 60 miles per hour, times the time, which we also don't know, equal to x. Now the other car. What do we know about this other car? Beautiful red car, huh? Well, we know, let's go ahead and call this distance 2, is going to be equal to rate times the time of this car. We don't know the distance it traveled, but we do know the rate was 45 miles per hour, and the time, we called it x. Question is, how come they both have the same variable for their time? Well, because when their distance between them reaches 420, we have both of the cars stop. And that's how we figure out how far they each respectively traveled. So now, what I know is that the distance this car here traveled, plus the distance this car here traveled, should end up equaling 420. Let me go ahead and write that down in math. The distance of the first car plus the distance of the second car should equal 420. Well, what is the distance of the first car? It's 60x. Plus, and the distance of the second car is 45x. Equals 420. Hey, alrighty, let's go ahead and add those up. So 60 plus 45, that's going to be 105x equals 420. Okay, we're going to have to divide by 105 from both sides. Okay, I don't know how to do that in my head, so I'm going to go ahead and do that on the side with my scratch work. So you want to see how quickly 105 goes into 420. Well, let's do a guess. 105 times 3 is going to be 15, 3 times 0, 1, 4, 3, 345. Well, that's almost 420. Let's try another one. How about if we go into it 4 times? Okay, so that'll be 20. 4 times 0 is 0, plus 2. 4 times 1 is 420. Hey, look at that. It goes into it perfectly 4 times. So, x is going to equal 4. So what is my answer? Well, t was in terms of time. So in how many hours will they be 420 miles apart? In 4 hours, they will be 420 miles apart. Period. Okay, let's take a look at the next example, which I believe is the last example, for this section. Example 4. Find 3 consecutive integers such that the sum of the first and the second is 43 less than 3 times the third. Whoa, some odd information there. But let's pause and think about what we're talking about. We're talking about 3 consecutive integers. What does consecutive mean? Well, it means one after the other. So for example, if I was talking about integers, which those are not fractions, that would be 1, 2, 3, 4, and so on. Consecutive would be this one, 1, 2, and 3, right? They're one after the other. So how do I go from 1 to 2? Well, I just add 1 to it, right? Then how do I go from 2 to 3? Well, I just add 1 to 2. So let's use this concept. I'm going to go ahead and say, let x equal the first integer. How would we describe the second integer? Well, if this was x, all I have to do is add 1 to it to get to the next number. So that means that x plus 1 is the second integer. I need 3. So, if I start at this first integer, how do I get to the third integer? Well, I just add 1, 2 to it. So x plus 2 will get me to the third integer. Okay, well, we now know what our variables are, but we need to create an equation. So what are we given? We're told that the sum of the first and second is, okay, note this, very, very important. Whenever you see is in a problem like this, that is your equal sign. So this is saying the sum of the first and the second is equal to 43 less than 3 times the third. Let's translate the first part. Sum of the first and the second. Well, the first one is x, and the second one is x plus 1. So I want the sum of these two. And I want that to be equal to, let's see, what do we have on this side? It's 43 less than, so we're going to be subtracting 43 from what? 3 times the third. Well, 3 times the third would just be 3 times x plus 2, and I'm taking 43 away from that. And there's my equation. I'm going to go ahead and write that a little better down here. So I have the sum of the first integer and the second, and that is equal to 3 times the third minus 43. And there we go, we have our equation. So let's go ahead and solve. So we have 1x and 2x. That's going to be 2x plus 1 is equal to, let's go ahead and distribute that 3. We'll get 3x plus 6 minus 43. We still have x on two sides, so I'm going to go ahead. Before I do that, let's combine these two. So that's going to be 6 and 43, so that should be 37. Negative 37. Okay, I'm going to go ahead and add 37 to both sides. And I'll get 2x plus 37 equals, oops, sorry, that should be 1 plus the 37, so that should be 38. Let me go ahead and erase that. Let's make our work neat. Okay. So 38 equals 3x. Okay, still solving for x. Let's go ahead and minus 2x from both sides. And we get 38 equals x. Ooh, are we done? No, because we want to know the three integers. So x equals 38. Well, that's my first integer. So that's going to equal 38. My second integer, I just add 1 to that. So that'll be 39. And my third integer, adding 2 to that, that's going to be 38, 39, 40. So I'll go ahead and write that out. The consecutive integers are 38, 39, and 40, period. And that is it. We are done for this section. Once again, if you need any help reviewing any of these problems or any of the other skills required in these problems, please come by my office hour or send me an email.